So I mentioned these two methods, the support method and the suspension method. So I want to show the suspension method. You have an odd-shaped object. Choose one of the holes. This one? Yeah. Okay. So it needs to be suspended twice from any point. So I have tiny holes here on the side, and the student chose one hole. So I'm suspending it, and I need a plumb line. I have a fancy one. Later I'll show a simple one. So plumb line can be any piece. The simple one, I'll have a nut on a string. This is a little bit fancier. So there's one principle behind. When an object is suspended, its center of mass, which is unknown, still unknown, but it always seeks the lowest point possible. So when it has a choice, right now it swings, eventually swinging slows down, the more friction we have, and then the center of mass is always beneath the point of suspension at the lowest position. So it must be somewhere along this plumb line. So I've marked it. Now I'll tape a plumb line on. So the plumb line is, I'll show again. I've marked it. So here's the plumb line. Choose another hole, not too close at it.
Right here.
This one here?
Yeah.
Okay. This is the one. But you could choose any other one, so I've gave you a choice. It comes out a little bit more accurate if they are far apart. If they're close together, one needs to work exactly. It works always. But here we want to work quickly. So we know the plumb line is somewhere on this line. We've marked it already. So now with the new suspension point, it's somewhere along the new plumb line. So I'll mark the new plumb line. Tape that on. So we know that the center of mass is somewhere along the first plumb line and somewhere along the second plumb line. But where is it? There's only one possibility that satisfies both conditions, where it's on the first and on the second plumb line at the same time. Which one is it? You point at it. Right here at the intersection. Now let's see whether that is true. I'll suspend one more time just to prove. Let me mark the intersection first. right there. So that's the center of mass, and that is the suspension method. That works always. Support method works only when we have something to hold on. But now watch. If I put my thumb right here, I can support. So now that you know where the center of mass is, when I support it there, that also proves it. So here are the two rules. Suspend the body twice. The center of mass is at the intersection of the plumb lines, and that's called a stable equilibrium. The support method is an unstable equilibrium. Why? I'll show. With a stable equilibrium, if I disturb it a little bit, it goes back to the equilibrium when the point, this is a suspension method where the point is beneath the point of suspension. The support method is this one where it's above the point of support, but it needs to be exactly above. If it's a little bit off, then it's unstable. So the suspension method is a stable equilibrium. The other one is an unstable equilibrium. So it's an equilibrium when it's exactly supported. When it's a little bit off this way or that way, then it's not stable and goes to the other equilibrium position where it's suspended. So now let's use the two methods with the teddy bear. The suspension method, the support method. I'm supporting the teddy bear at its start. So this must be the center of mass. And now let's use the suspension method. So you can suspend from any part of the body, say from the ear, and then the plumb line goes through the center of mass, the red dot, from the other ear, from the foot. So do you have a center of mass? Does your body have a center of mass? How can you find out? Suspend? Yes, one could. Would not be very pleasant. So in the lab, you'll find out with a support method. So something to look forward to. That's what you'll do in the lab to find out your center of mass. So here they have an odd-shaped object. Does it have a center of mass? Yes or no? Yes. Where is it? I found already out. And have it marked by the dot. So the plumb lines are marked on. I suspended a few times. And at the intersection of all the plumb lines, that's where the center of mass is. So that's where I'm supporting it right now. Where is the center of the United States? Where is the center of the state of California? Where is the center of mass, Massachusetts? How can one find out? So one of my former students, he had a summer job, and it was a company who delivered refrigerators, and they were not doing well financially. So they were thinking, where should we put our warehouse, at which spot? They were allowed only to deliver in their state. Where should we put our warehouse so that we have the shortest distances to drive? And what did my student say? Put it at the center of mass of that state. So at the center of that state. How can one figure that out? So when it comes to the United States, cut out a map, put it on a cardboard, suspend, mark the plumb lines once, twice, and then find out. You can also check with the support method, find out, oh, it's right at the Kansas-Nebraska border. Where's the center of mass of our state? Almost here in Fresno. North Fork more accurately, so you can find that out in the lab. And a student with a summer school, the center of mass of the state of Massachusetts. So again, the plumb lines, once, twice. So this is the state of Massachusetts, and the center of mass is, my student found out, right at the time of Worcester. Okay, so there is actual practical use of understanding the center of mass. More uses the next time. I want to summarize for today and repeat one more time the two methods. To find out the center of mass of an object. One is, so say the center of mass of a spoon. You can do that at Thanksgiving when everybody is at the table and they want a little bit entertainment, and Uncle Paul wants to know what do you actually learn in school. And then you grab one of the spoons. I have to take off my glasses and show the support method. You balance it right on the bridge of your nose, support method. And the other one is the suspension method. And you balance it from the tip of your nose. That's all I have for you today. See you all on Wednesday.